Hello everyone, welcome back to another video in the neural network series. Today we'll be adding the final piece to our neural network by making our training loop. We have all the tools that we need to get a network that trains itself. All we need to do is put them in the correct order. The basic idea behind our training loop will be that we will essentially let our network train for a couple thousand iterations, and then in each iteration the network will change its parameter values based on the desired output and the network's predicted output, which obviously uses backpropagation and gradient descent. Alright, let's jump into the code then. And we're just going to go ahead and call this method train. And this train method will take our network, which I will call model. It will take x, which will be our inputs, and it will take y, which will be our desired outputs. And then the last two hyperparameters it will need will be our learning rate, which is used by the gradient descent method, and then the number of epochs, and I will set a default value for this of 10,000. Okay, let's move on to the body of the code. We will have a for loop, so it will be for epoch in range epochs, colon. So pretty straightforward. Next, we want to be doing something that's called stochastic gradient descent, which is really just a fancy way of saying that our inputs that will be used to train the network in each iteration will essentially be random. And so in order to get a random input at each epoch, we will do index equals, and we'll utilize the NumPy random functionality, so np.random.randint. Randint essentially produces a random integer, and we want our range to be from 0 to the size of our inputs, so x.size, and this upper limit is exclusive, so it doesn't include the final number. Okay, we can then go ahead and get our random input, so x equals capital X bracket index, and so this index was randomly generated, and now I'm just accessing the value at that randomly generated index, and then I'm going to go ahead and reshape this input as a 1x1 matrix essentially. And then the next thing is we can go ahead and get our desired output value, so y underscore true, and this would be just y bracket index. Cool, now we can actually train our method. So the first thing we're going to need from our network itself is the predicted output value. So I'm going to do y underscore pred equals model, which is our network, and we're going to go ahead and call the forward method, and then this essentially calculates the predicted output and stores it in the class attribute. So now we have to essentially use this predicted output from the network to calculate all our gradients, and if you recall, we do that with our backpropagation method. So next we will call model.backward, and we will be passing in x comma y true. Lastly, we need to use all these gradients to actually change our parameter values. So for that, we'll be using the gradient descent method, so model.gradient descent, and we'll be passing in our learning rate, so learn underscore rate. We can add a print statement just so we can actually track the progress of our network. Okay, with that we are officially done. Now we can go ahead and train our network and see if it actually works, if it actually fits to the parabola that we initially had. So let's first go ahead and make our network. So we will do model equals network, and then I'll pass in 1, 1, since we have one input and one output. And now we can train the network using the train method. So train, pass in our model, our inputs x, our outputs y, our learning rate, which I'll set at 0.001, and the epochs, which I'll just keep at 10,000. If we go ahead and hit enter, shift enter, you can see that our network starts to train, and over time our losses are decreasing, which is a good sign. It goes up a couple times, but the overall trend is that the losses are decreasing, which is what we want. Okay, now we can actually visualize the results by plotting the predicted values versus the actual values. So to get all our predicted values at once, we'll do y underscore pred equals model.forward, and then we will have x.reshape 1, 100. So I'm just reshaping our inputs to a row vector because that's the required vector by our for method. And then we can go ahead and plot our values. So I would do x, y pred, and then I'm gonna go ahead and put a bracket 0 in there just so it actually quote unquote flattens the list. It just doesn't have a matrix in there. Otherwise, you'll actually get an error. And then shift enter, and boom, we have something that's pretty close to a parabola. And so you can see that we have officially actually trained our method, and the outputs this time are not completely meaningless. With that is all for today's video. We have now finished our neural network series, and I do plan on coming back to this series sometime and making our neural networks tackle some more complex problems like classifying images and other categorical data sets. Let me know in the comment section what else you would like to see, just in general, or just related to neural networks. I think maybe implementing some sort of a atom optimizer might also be a good idea. And that's all. So thank you, and I'll see you next time.